Welcome to Online Maths TV. Today we have a challenge on the board. It's an exponential equation, but a very tough one. The question is bracket open the square root of 7 minus 4 into the square root of your 3, close bracket, all raised to x plus the square root of x plus 2, or equal to your bracket open 2 minus the square root of 3, the close bracket, all raised to x plus the cube root of 2x plus 4. What will be the possible value of x that will satisfy this expression here? The question was actually dropped by one of my subscribers, and he said he saw this question somewhere, but the explanation, the approach to it wasn't clear to him, and he said I should work on it for him to gain more insight into exponential equations or challenges of this kind. All right, so you're welcome to Online Maths TV, and my name is Jakes Anemo, as you all know. And if you're new to this channel, kindly subscribe. And when you subscribe, turn on the bell notification button. That will enable the YouTube algorithm to notify you whenever we drop that amazing video that you look forward to. With that being said, let's go into today's challenge without much waste of time. So here we take our solution to this problem, this challenge. Now, without writing the question down, we're going straight to solve. At first, when I saw this question, I was taken aback. But after much thinking, after much ransacking my brain, I was able to come up with something unique. All we need to do is to express this base in this format so that the base can take care of themselves and equate the exponent. So how do we go about that? So we are going to take this out first. Now, if you look at this expression, let's put it down. Here we're having your square root of 7 minus 4 into the square root of 3. This is equal to, if you look at this carefully, here we are having the square root of 3. Here we're having minus 4. So we think of an algebraic identity from which we can get something of this expression. Now, if I decide to equate this to something, but before that, remember the algebraic identity, which says that if you have your x minus y all square, this will eventually give us, this all square please, this will eventually give us your x squared minus 2xy there plus your y squared. You remember this? Good. Why am I bringing this identity? It's because here we have a square root symbol. So we are looking for something that will be inside the square root that can cancel out this square to expose our entity here. Okay, so here, because we are having x here, I'm going to make use of a different alphabet. So we can relate this to, let's take m. So we have m minus n r squared. Now, if we open up this using this identity, this is equal to the square root of your m squared plus your n squared minus 2mn. Okay, let's erase this. Minus 2mn. Good. So it tells me that the square root of our 7 minus 4 root 3, this is equal to the square root of your m squared plus n squared minus 2mn. Good. Now let's look at this now. With what we have here and here, this can go with this. Okay? In other words, we are taking the square of both sides. So if we square both sides, this will now leave. So once this leaves, then we now have your 7 minus 4 root 3. This is equal to your m squared plus n squared minus 2mn. Now, from this expression, look at this. we can equate this to this. Okay? We can equate this to this. So if we equate this to this, we can equally equate the whole of this here. Okay? We can equate this to this. All right. So let's equate. So this now implies m squared plus your n squared. This is equal to 7. So let's take this as our equation 1 and then our equation 2. This will now give us here your 2mn. This will now be equal to your 4 root 3. Because the minus, we cancel out the minus, so we are left with it. So let's give this equation 2. Now from equation 2, we can make m the subject of the formula. So if we go ahead to make m the subject of the formula, let's say make m subject of the formula. If we do that, we're going to have 2mn all over 2n. This is n, please. This is equal to the 4 into square root of 3 all over 2n. This, we go with this. We are left with 2 here. Then this, we go with this. So our m, let's continue on this side. So now have m is equal to 2 root 3 all over n. So let's give this equation star. Okay. So if we decide to give this equation star, we can put equation star into equation 1 here. So if we do that, we're going to have this to be your 2 root 3 all over n r squared plus n squared. This is equal to your 7. So if we open up this, we're going to have this to be 4 dot 3 all over n squared plus your n squared equal to 7. If we multiply through by n, we're going to have this to be your 12, okay, all over n squared times your n squared plus n squared times n is n squared equals to 7 dot n squared. So this leaves the system. We now have your 12 plus your n to the power of 4 equals to 7n squared. So we can equally rearrange this. So if we rearrange this, we're going to have here n to the power of 4 minus 7n squared plus 12 equal to 0. So this is a 4th degree polynomial equation. So as a 4th degree polynomial equation, we could use the trial by error method to get the first factor, then using to do a long division to get your other 3 factors. But look at what I want to do here. I want to rewrite this minus 7n squared. So how do I go about this? This will now give us your n to the power of 4 minus 3n squared minus 4n squared plus 12 equal to 0. Because minus 3n squared minus 4n squared will still give us this. At this point, put this in bracket, put this in bracket. We can factor n squared here out. So we have here n squared will now give us here n squared minus 3, close bracket, minus, here we have 4, is common, so 4 here will give us n squared, minus times plus will give us minus, then here we have 3, everything equal to your 0. You discover what we have in the 2 brackets are the same. So we only take this out and take this out. So we now have this to be bracket n squared minus 4 bracket n squared minus 3. This is equal to 0. So at this point, we can succumb to the zero product rule, okay, where we equate this to 0, equate this to 0. So let's continue on this side of the board. So this now implies that our n squared minus 4 is equal to 0, or n squared minus 3 equal to 0. We take this to this side, we take this to this other side. So we now have n squared is equal to 4 or your n squared is equal to 3. As you know, we take the square root of both sides, and immediately we do that, we add our plus minus, we also introduce our plus minus here. So with this, we now have this, this other side squared it. So this leaves, this leaves. So we now have our n is equals to plus minus 2, or our n is equals to plus minus root 3. Okay, so but here, look at what I did here. I want to ignore the negative signs, okay, the negative root. And so here we'll be dealing with our n1 and n2. We have plus 2 or plus root 3. Okay, now that we've got our n to be 2 or root 3, we can now solve for our m. Remember our equation star, okay? So we've made m the subject of the formula already. All we need to do is to substitute. So from here, when I say here, from equation star, we have our m is equal to 2 root 3 all over your n. So when n is 2, what is the value of m? This is easy. You just matter of 2 into the square root of 3 all over your 2. 2 goes with this, so this will now give us root 3. In other words, when n is equals to 2, m is equals to root 3. Then we now check for when n is equals to root 3. So let's take this as our 1, m1. This is our n1 and n2. So we now have here m2 is equals to, again we have 2 root 3 all over n, which is equals to 2 root 3 all over our n is root 3. This leaves, which is equals to 2. Easy. Now that we've got this now, what we do, we go back to our expression. So it shows that this you have here is equivalent to this, which is so 2 minus root 3. Got the answer from here now, right? So let's continue on this side. So from here, it also implies that the square root of 7 minus 4 root 3 is equal to the square root of your bracket, your m, which got it to be 2 minus root 3 all squared. Remember? Okay, from the first identity I used in representing this. So if this leaves, so we now have here 2 minus root 3. Which shows clearly that what we have here is equivalent to this. We've just shown that now. All right, so from this proof so far, we can rewrite the original equation as your bracket, your 2 minus the square root of 3, or to the power of your x plus the square root of your x plus 2. Okay, this is equal to bracket your 2 minus the square root of 3 close bracket r to the power of your x plus the cube root, okay, the cube root of your 2x plus your 4. All right, now that the bases are now the same, what happened? We can equate the exponent. So equating the exponent will now give us your x plus the square root of your x plus 2 equal to your x plus the cube root of your 2x plus 4. Good, we are almost there. Now we look at this again. Here we have plus x, here we have plus x. So if we collect like terms, or if we rearrange this will leave. Then we are now left with this. The first thing we do here, we have two different radicals. So we are going to take the square of both sides and at the same time take the cube of both sides. So if we take the square of both sides, this will leave. And if you take the cube of this side, this will also leave. So in all, we're going to have our expression to be your x plus your 2r to the power of 3, then equal to bracket your 2x plus your 4 all to the power of 2. Any confusion with this? We cannot use binomial expansion to open up this. Also, you use binomial expansion to open up this. Remember your Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Remember? Okay, so if we apply this, here we have your third power. So we're going to use this coefficient. Why this? We use this second coefficient. So let's go ahead and open this. If we do that, your x to the power of 3 plus, okay, the coefficient here is 3. So we have here your 3 dot, okay, your x to the power of 2 dot, your 2, remember? Okay, plus, then your 3 again, 3 dot, your x dot, your 2 to the power of 2, okay? All right, there, plus, then you have your 2 to the power of 3. Easy. All right, so we'll come to this side of the board again. We have this to be equal to, we use that same method to expand this. Okay, this will now give us here your 2x r squared plus your 2 dot, our 2x dot 4 plus 4 squared. Okay, so let's open up everything. We have here x to the power of 3, there plus, here we have 6x squared plus your 12x, there plus your 8. This is equal to 4x squared plus 4 times 4 will give us 16x plus 16. So we cannot collect our like terms to give us here x to the power of 3 plus your 6x squared minus 4x squared, the plus 12x, the minus 16x plus 8 minus 16 equal to 0. This will give us x to the power of 3, the minus plus your 2x squared, then you will have minus 4x, then minus 8 equal to 0. Here we have a third degree polynomial equation again. So we could use the trial by error method, but here, if you look carefully, let's quickly group this and this, bracket this and this. So if we factor out your x squared, we're going to have here x squared, bracket left with x, there plus, here we have 2, close bracket, minus, here we have 4 is common, so we have here 4 plus, because minus times minus gives us plus, we have 2 equal to 0. So what we have in this bracket and what we have in this bracket are the same. So we cannot take this outside and this. Okay, so let's continue on this side of the board. All right, so if we write this, we're going to have here x to the power of 2 minus your 4, bracket, your x plus 2 equal to 0. So this gives us, if we equate this, applying the zero product rule, we have x squared minus 4 equal to 0, or your x plus 2 is equals to 0. So we now have this x squared is equals to your positive 4, or your x is equals to minus 2. Take the square root of both sides. And immediately you do that, introduce your plus minus, this leaves. So we have x is equals to plus minus 2. Or here we have x is equals to minus 2. But already we have minus 2 here already. Okay, so what does it mean? It means our x is equals to plus or minus 2. So in order, we cannot say, therefore, our x is equals to your plus minus 2. All right. Okay. All right. Though tough and kind of stressful, but this marks the end of the tough exponential equation. Okay, so if you put this value plus or minus 2 into this expression, it will satisfy the equation. All right, so to my viewer that dropped this challenge, I want to believe you must have learned something from this approach. But if it is not too clear to you, still drop it in the comment section. But if it is clear to you, also drop it in the comment section. Just leave a comment. Could just be thanks Jay, could be well done Jay for this approach. All right. So to others, if you have a better way of solving this tough exponential challenge, drop it in the comment section too, so that we can equally learn from you. All right. We are good at replying to comments. And yeah, we welcome criticism, okay? But it should be constructive criticism, okay? It is through your criticism that we can actually grow, okay? We are open to learn new skills, even as we unlearn old skill, okay? Thank you so much for always be there. Again, never thought that I forgot my name due to the rhetorical solution, the rhetorical solving we just made here now. My name is still fresh in my head, and my name is Jakes Anemo. All right, if you're new here, do not forget to subscribe. When you subscribe, that is when you get our videos when they are released. Yeah, we release powerful videos all the time for your learning, for your fun. And thanks for always be there. Bye for now.